Okie dokie, artichokes. Here we go, here we go. We're going to do a little lesson, Unit 3, Lesson 3. Can you say it with symbols? Okay, ready, set, let's go, let's go. All right. So, they want us to sketch this triangle, so I'm going to sketch two triangles. So I'm going to sketch this one, bada bing, and I'm going to sketch this one. That's going to look like they are the same, right? So there's that right there. Now notice they gave me information. So the information they gave me was that ML is congruent to ZJ. So I need to put that information in my diagrams. So I'm going to call this M, I'm going to call this L, and M and Z must correspond, and L and J must correspond. Now they told me that side is congruent to that side. They also tell me that LR, well L, this must be R, is congruent to JB, this must be B. I'm going to put my notation there. And angle L is congruent to angle J. So that is the sketch of the two triangles based on the congruent statements. Now, let's do the congruency pattern. Well, that pattern is side, angle, side. Remember, order matters. So side, angle, side. All right, and the congruent statement would be triangle MLR is congruent to triangle. Make sure corresponding parts. So M corresponds to Z, L corresponds to J, and R corresponds to B. Boom, that's it. Done. That's it. Okay, let's keep going. All right, we'll sketch again. I'm going to draw a triangle. Draw another triangle. Okay. WB and WB is congruent to Q, R. Boom, that's done. BP, this must be P. RS, this must be S. Boom, boom. And then WP, right there, and Q. That congruence pattern is side, side, side. And do they want a congruent statement? They do. I'm going to do the congruent statement on this side. It's going to be triangle WBP is congruent to triangle QRS. And that is done. All right, moving on. Now this first thing, I already did this, right? That was what I just did on that last page. So let's do this one right here. All right, I got this. Woo, woo. I got this. Woo, woo. CY. CY. It's going to go to RP. Angle Y is congruent to angle P. Angle E, this must be angle E, is congruent to angle B. Like so. The congruence pattern is angle side, no, is angle, angle, side. Angle, angle, side. The congruent statement is triangle CYE is congruent to triangle RPB. And that is by angle, angle, side. Okay, let's do this one. Sketch the triangles. Boom. Boom. All right, BC. BC is congruent to JK. B8, this must be 8, is congruent to JM. And angle B is congruent to angle J. That is side, angle, side. So congruence pattern, side, angle, side. Congruent statement, triangle. BAC is congruent to triangle JMK by side, angle, side postulate. All right, good job. Olivia is studying triangle ABC and quadrilateral ADEG is shown in the figure. Her teacher has told the class the quadrilateral ADEG is a rectangle and that GE bisects both segments BC and AB. The assignment is to prove that these are congruent in a two-column proof. Okay. Let's do it. All right, there was some information that was incorrect, and I believe it was here. This should be AGE. Okay? All right. So this is Olivia organizing her thoughts based on this picture. GE bisects BC. Okay, so that implies that that is true. And it also bisects those. So that is also true. I know that BE is congruent to EC, and BG is congruent to AG by definition of bisectors. I know that AG is congruent to DE because they are opposite sides of a rectangle, right? And I know that BG is congruent to DE by the transitive property. Okay. All right, I'm going to take that information first. So I'm first going to deal with that, okay? So notice my goal is to use that information to answer question 5. So this is the given, and this is what I'm trying to prove. All right? Let's do it. Okay. So the first two statements are given for me because they are givens. All right? But now I'm going to use this information up here. So I'm going to go right here. And I'm going to say, right, that was given. So that was right there. BE is congruent, so that's what I'm going to do next. So I'm going to literally just follow this. BE is congruent to EC, and that's by definition of bisector. Right there, sorry. They also told me that BG is congruent to AG. That's definition of bisector. They told me that AG is congruent to DE. So AG is congruent to DE. That's because they're opposite sides of a rectangle. Rectangle are congruent. Okay, so opposite sides of a rectangle are congruent. We know that's true. They're parallel and congruent. All right. And then step 6 is that BG is congruent to DE. And the reason that's true is because of a new property called transitive property. See how BG is congruent to AG and AG is congruent to DE? So because this is congruent to that and this is congruent to the same piece, they must be congruent to each other by the transitive property. Basically, it's substitution. Okay, so that part is done. Now we slide down to here. Okay, so all angles in ADEG are right angles. And that's by definition of rectangle. Okay? Now I know that AGE and BGE are a linear pair. So 90 degrees. And that's a definition of linear pair. Okay, so now they're saying, okay, by the way, this right here, right? That's boom and boom. And they're also saying the same thing about ADE and CDE. And that's by definition of linear pair. Okay, 10. Okay, so let's put in some more information. Okay, so ADE, right? So we know that's true. We also know that that is true because we said that up above, right? We said that right here by the transitive property that BG is congruent to DE. Okay, so that's true. So we have that side, and that angle. So side-side angle is not a postulate. Okay, so what else do I know? Oh my gosh. Well, I know this. I know that BE squared, I know that BE squared is equal to BG squared plus GE squared. That's Pythagorean theorem. That's a right triangle. And I also know that EC squared, EC squared is congruent, equal, talking about measurements, equal to ED squared plus BG squared. No, sorry, DC squared. Okay, so now I know some things, and that's also by a Pythagorean theorem. Okay, so what do I know? Well, don't I know by up here that BG and DE are congruent? And don't I also know that GE and DC are congruent? Hold on. GE, no, I don't know that. BE and EC are congruent, right? So by this right here, GE must be congruent to DC because they both equal BE minus BG squared. So this is congruent to that, this is congruent to that. So that's by transitive. Okay, so then I know what? Then I know that this is congruent to that. Okay, now we got it. So triangle, that was tough. Triangle BGE. It was the Pythagorean theorem part that was tough. So BGE is congruent to EDC by side, side, side. Dang, that was tough. Okay, let's do it. Let's keep going. Oh, this is number 6. Number 6 is long. All right, let's do this. Sorry, did I give you enough time on there? I'm going to do that right there. Pause for a minute. Hello, okay. And I'm moving on. Here's number 6. Number 6. Okay, so perform the following transformation on ABC. Okay, I'm going to need some paper from Patty. Hi. I'm going to need a straight edge too. So I got those two things. Okay, let's do it. what's the first thing I'm going to do? Reflect ABC over LK. Okay. So, you go like this. I'm going to mark my foundation points, anchor points. And then I'm also going to go like that, because that's the end of that line segment, and like that, because I want to be able to reflect this over that and mark where they are. So I'm going to line these up like that. Okay. And now this is my new triangle. Okay, and this is A prime. This is B prime. And this is C prime. And I'm going to connect them, and I'm going to do a good job. So I'm going to use a straight edge, okay? You got to use a straight edge, people. I'm going to mark you down for this sloppy work. Pride in your work, always. Always pride in your work. All right, there's that. Okay, that part's done. What do you notice about the line segments A prime, B prime, and C prime? Well, I got to draw them first, so let me do that. Okay, so I'm going to draw C prime and draw A prime. I'm going to draw B prime. They're all parallel to each other. Compare the line segments AB, BC, and CA to, hold on, A double prime. I must have missed something. Where am I? Compare the segments AB, BC, and CA, A, B, B, C. What is this? What is the same and what is different about these segments? Okay, the same is they're the same length. What's different is their orientation. That means they're pointing different directions, right? This is pointing this way, this is pointing this way. So the orientation is different. All right? Okay. Translate ABC down 8 units and right 10. Okay, so I'm going to go here. Down 8, right 10. So down 8. Right 10. That would be A double prime. Okay, down 8 over 10. B double prime. Down 8 over 10. C double prime. Use the compass there. I'm sorry, the straight edge. Okay, there's that. What do you notice about line segment A double prime? Okay, we have to do line segments again. And last one, CC prime. It's right there. They're parallel. Parallel. Oh, jeez. You can't even see this. Parallel to each other. Okay. Okay. Okay, compare the segments AB, BC, and CA to A double prime, B double prime. What are the same and what are different? Okay. Well, the orientation is the same. The size is the same as well. But it's in a different quadrant. Okay, so notice that triangle is in quadrant 2. That triangle is in quadrant 4. So that's in quadrant 2. That's in quadrant 4. Quadrants go like this: 1, 2, 3, and 4. Okay, translate ABC down 10 units and reflect it over the y-axis. Okay, so I'm going to go down 10 and call that B triple prime. So down 10, and then reflect over the y-axis. I'm going to get this out of here because it's going to get in my way. All right, so I'm going to go down 10, that's right here, and then reflecting it over the y-axis means I'm going to be 10 units away right there. So B double prime. I'm going to go down 10, so 5, 10, and now reflect that over the y-axis. So 8 units that way, 8 units that way. That is A prime. Sorry, A triple prime, B triple prime. This one. Right there. And then reflect over the y-axis. So that would be there. And then we connect it. This is a lot of stuff going on here. A lot of stuff. This A double prime goes with this. And this C triple prime goes with that, okay? So here's this. Boom. Boom. And boom. There it is. All right, what do they ask us? What do you notice about the line segments A double prime, okay, it's hard, all these line segments are getting a little convoluted. Yeah, so I'm going to keep going, but I'm going to do a different color. Okay, there's that. There's that. And there's that. I don't see a relationship. Nothing special. I'm not seeing it. Nothing special. They're not parallel. They're not perpendicular. I just am not seeing any relationship at all there, okay? All right. Compare the segments AB and BC to AB. What is the same and what is different? All right, the size of the shape is the same. Same size, different orientation. Woo, that was tough. All right, kiddos, that's it. My job is done here. Stay strong, be great. See you soon. Bye.